Today, we will look at probability, our last topic under the word problem series. In this chapter, we will look at definition and properties. We will look at multiple events, probability of failure, and the domino effect. Now here, we will start off by looking at what probability is. Now, probability is a quantity that expresses the chance or likelihood of an event. Now, for events with countable outcomes, probability is defined by this fraction. Okay, that's number of desired or successful outcomes all over total number of possible outcomes. Now, this fraction here assumes that all outcomes are what? Equally likely. Now, as a simple illustration, tossing a coin has two possible outcomes: heads and tails. Now, the probability of landing on heads is what? Is half, because you have heads and then you have tails. So if you flipped your coin, okay, you want to find the probability of landing on heads, then it's what? This one, 1/2, because there are two possible outcomes, or two total outcomes. It can be head, it can be tail, and so the probability of landing heads is what? Half. Now, I once met a guy who said that the lottery has two outcomes, okay, which is what? Win or lose. Now, does this mean that the probability of winning the lottery is half? Certainly not. To correctly calculate the probability of winning the lottery, you must find all the possible equally likely outcomes. Now, one key aspect in most probability problems is finding how to break down a situation into equally likely outcomes. Now, we have here an example, okay, which says a fair coin is tossed 3 times. Now, we have this example here which says, if a fair coin is tossed 3 times, what is the probability that it will turn up tails exactly twice? Now, here we have to formulate equally likely outcomes in terms of the outcome of each flip. So here we get heads, heads, heads. Okay. Then we have heads, heads, tail. Okay, then we have heads, tail, tail. Okay, we have heads, tail, heads. Okay, and then we can go on, and then we can have here tail, tail, tail. Then we have tail, tail, heads. Then we have tail, heads, heads. And then we have tail, heads, tail. So you have how many total possible outcomes? We have 1, 2, 3, 4, 5, 6, 7, 8. Now, if you have trouble formulating this list, please use a counting tree which breaks down the possible outcomes step by step. And so here you can start off and say, this is what the first toss of the coin, and when you toss the coin, it can land what? Heads or tail. Okay, and if it lands tail, okay, and then we flip the second time. Here we flip the second time. Okay, we can have what? Again, heads or tail. If it lands heads, we can flip the second time, and then here we land what? Heads or tail. Okay, here we flip again, we have what? Heads, and then here we have tail. Okay, then here you flip third time, you have heads, and then here you have what? Tail. And then here you flip the third time, you have what? Heads, and then tail. And then here you flip third time as well, and then you have what? Heads and tail. So here you have what? Head, head, head. So here is what? Head, head, head. And then here you have head, head, tail. Head, head, tail. Okay, then here you have head, tail, head. Head, tail, head. And then here you have head, tail, tail. Head, tail, tail. And then here you have what? Tail, head, head. Tail, head, head. You have tail, head, tail. Tail, head, tail. You have tail, tail, head. And then finally you have tail, tail, tail. Okay, so this is how you can use a counting tree to find your total possible outcomes. Now we can also use the slot method to find the total number of our the total number of possible outcomes we have. So remember from the previous topic, combinatorics, we studied the slot method, okay, where here you have what? 3 toss of a dice, 1, 2, 3, and you realize that for each toss you have 2 possible outcomes, so which is head or tail. So here is 2, here is 2, and then here. So for each of the 3 toss of the coin, you have 2 possible outcomes. You multiply all these possible outcomes together, and then you have what? 2 times 2 times 2, which is what? 8. And then we have how many total possible outcomes? We have 8 total possible outcomes. Now, so here the 8 outcomes are equally likely, because at each toss, landing a head or tail is equally likely. Now, if you examine our list, okay, this list, you will realize that 3 outcomes turn up tails exactly twice. And so here you have what? 2 tails here. Here you have what? Exactly 2 tails. And then here you have what? 2 tails. So 1, 2, 3. Okay, so our desired outcome, which is exactly 2 tails, is what? 3. 1, 2, 3. And so you have what? Desired outcomes over total outcomes. So we have desired outcomes in this case is what? 3. Total number of possible outcomes in this case is 8. And so for this particular example, the probability of what? Turning up tails exactly twice is what? Is 3/8. Now here we have 2 properties that we want to look at. The first one is 1 is the greatest probability. Now this is the certainty that an event will what? Okay. So for example, the probability that you roll a die once and it lands on a number less or equal to 6 is certain. And so here you realize that the number of successful outcomes over the total number of possible outcomes is what? Is 6/6, and the answer is what? 1. Now here the lowest probability is what? Is 0. Now a probability of 0 means that an event will not occur. So here, for example, the probability that you roll a die once and it lands on a number greater than 6 is impossible. So you know that a die has what? Numbers between 1 and 6. And so if you are asked to find the probability that if you roll a die once it will land on a number greater than 6 is not possible. And so number of successful outcomes will be what? 0. And then you have total number of possible outcomes is what? 6. And then this is what? 0. Now here we turn attention to multiple events, and then we'll examine the AND versus OR operations. Now, probability problems that deal with multiple events usually involve 2 primary operations. Okay, multiplication and addition. Okay, the key to understanding probability is to understand when you must multiply and when you must add when dealing with multiple events. Now assume that X and Y are independent events. Now to determine the probability that event X and event Y will both occur, multiply the 2 probabilities together. Okay, and then here we have this example which says, what is the probability that a fair coin flipped twice will land on heads both times? Okay, so you here straight away you will know that this is an end problem. Now, because it is asking for the probability that the coin will land on heads on the first flip and the second flip. So the probability that the coin will land on heads so probability of landing heads, okay, on the first flip is what? Is half. And the probability that the coin will land on heads on the second flip, okay, is also what? Half. Now, these events are what? Independent of each other. Okay, therefore, the probability that the coin will land on heads on both flips is what? Probability of landing heads on both flips is what? Half times half, which is what? 1/4. And remember, we are multiplying because this is what? An end problem. And when we deal with a problem which is an end problem, those two events, okay, are typically independent, which means they can both occur. Now, let us look at the OR, okay, problems. Now here, assume that X and Y are mutually exclusive events. Okay. Now, mutually exclusive events, cannot both occur. If you have two events which are mutually exclusive, then it means both events cannot occur at the same time. Okay, for example, if you flip a coin, you cannot land on heads and tails at the same time. Heads and tails cannot occur at the same time. It will be, either tails or heads. Okay, to determine the probability that event X or event Y will occur, we add. Okay, so take note. If you see an event which is OR, we add. So you typically, for these kind of events, you have to think of, whether the two events can occur at the same time or cannot occur at the same time. What I mean is that whether those two events are mutually exclusive events or are independent events. So your understanding of, these two concepts, is key to your ability to solve questions. Okay. Now let's look at this example. What is the probability that a fair die rolled once will land on either 4 or 5? Okay. Now here, so we know, as we have already spoken, this is what an OR problem, and because it is asking for the probability that the die will land on either 4 or 5. Now the probability that the die will land on 4 is what? Probability that the die will land on 4 is what? 1/6. Okay, and the probability that the die will land on 5 is what? Also 1/6. So here, probability of what? Probability that the die will land on 4 or 5 is what? 1/6 plus 1/6. So notice here that in this particular example, we are using the operation or addition. Okay, plus here it was multiplication. Okay, so take note of the difference. Okay, so here therefore the probability that the die will land on either 4 or 5 is what? 2/6, which is equal to 1/3. Now try your hands on these questions here. Now note that under all probabilities, up until now, we have assumed that the events are mutually exclusive, meaning that both events cannot occur. Now, what happens if the events are not mutually exclusive? Okay, meaning they can both occur, but it still falls under, an or problem. Okay. Now, if that is the case and you simply add the probabilities like we did in a previous example, then we will be double counting. Okay, we'll be double counting the instances when both events occur. So we have to, so what we have to do with such problems is that we have to subtract out the probability that both events will occur. And so here, if you have two, events X and Y, which are not mutually exclusive, and then you are given an or question. Okay, what you do is that because they are not mutually exclusive events, and these two events can occur at the same time, you treat it as an or problem, but then you have to take out the probability that both events can occur. Now we will take a look at this particular example, which says that suppose a box contains 20 balls. 10 balls are white and marked with the integers 1 to 10. The other 10 balls are red and marked with the integers 11 to 20. If one ball is selected, what is the probability that the ball will be white or will be marked with an even number? So here you realize that it's an or problem, okay, because it says that if one ball is selected, what is the probability that the ball will be white or will be marked with an even number? Now here, since we can list the balls, okay, so here you have 20 balls, 10 are white and marked with 1 to 10. So here we have all the white balls. White, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the other 10 balls are red. So you have 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Now, here the reason why I've listed, all the balls is to show you, why this, even though this is an or problem, okay, an OR problem, it's not, exactly your typical OR problem where the events, are mutually exclusive. Okay, which means both events cannot, occur at the same time. Now, if you start reading your question from here, if one ball is selected, okay, if just one ball is selected, what is the probability that the ball will be white? Okay, the probability that the ball will be white or will be marked with an even number. So if you look at these are the white balls, and then the even numbers are here: 1, 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. These are, so white are here, all these balls are white, and then all these, underlined balls are what? Are even. Okay. Now, what the challenge here is that there are some white balls that are also what? Even. Okay, so here we want white or even. Okay. However, if you look at the white balls, you realize that this one is both white and even. This as well is also white and even. And so we have to take out all these, balls to get just white and just even. Okay. And so since half the balls are white and half are marked with an even number, so you realize that you will go ahead and say that the probability of white is what? Is half. Okay, because half of the balls are white. And then you go and then you also say what? The probability of the balls being even is what? Is also half. And so from our OR problem, we can say probability of white or even is what? Half plus half, which is equal to what? 1. However, we know that this is what? Incorrect. Okay, because we must subtract out the probability that the ball is both white and marked with an even number. Yeah, and there are 5 such balls out of the 20. So here you have what? 1, 2, 3, 4, 5. Okay, and so when you set up your equation, it has to look something like this. It has to be P white or even is equal to what? Probability of white plus probability of what? Even minus probability of white and even. Okay, so here we can go ahead and say this will be what? Half plus half minus what? 5 over 20. Okay, or we could have said 10 over 20 plus 10 over 20 minus 5 over 20. And then here we get what? 15 over 20. 5 will go here, 4, 5 will go here, 3, and then you have what? probability of what? White or even is what? 3 over 4. Now here we will look at probability of failure, or 1 minus x. Now, as we have shown in the previous section, you can solve all problems by combining the probabilities of individual events. Okay. Now, if there are many individual events, combining the probabilities of all the events or all the individual events may be tedious and time consuming. Okay, so in such instance, the probability of the desired event not happening, okay, may be much easier to calculate. Okay, so let us say that a footballer shoots 5 times, okay, during a game, and you want to find the likelihood that he scores at least 1 goal. Okay, so if you try to calculate this probability directly, you will have to confront 5 separate what possibilities that constitute success. So here you'll be looking for what? You'll be looking for exactly 1 what? Goal. Okay, then you'll be looking for exactly 2 goals. You'll be looking for exactly 3 goals, exactly 4 goals, or exactly what? 5 goals. Now it will seem that you would have no option but to calculate each of those, probabilities separately and add them together, and this will be too much work. Okay, especially under timed conditions. Now, what alternative do we have? So as we have already discussed, we can consider the probability of failure. That is the probability, we can consider the probability of failure. That is, the footballer does not score at least 1 goal. Okay, now you have only one possibility to consider, which is what? 0 goals. Now for any event, the following relationship which we have here is true, which is what? Probability of success plus probability of failure is equal to 1. Okay, let us consider this example here to demonstrate what we've spoken about. Now, what is the probability that on 3 rolls of a die, at least one of the rolls will be a 5? Now we could list all the possible outcomes of 3 rolls of a die. Okay, and we'll have something like this: 1 1 1, comma 1 1 2, comma 1 1 3, comma 1 1 4, comma, and then etc. It goes on and on, and then we can determine how many have at least what? 1 5. But this will be very time consuming. Imagine you listing, so this one was what? The first roll of the die, it lands on 1. The second roll of the die, it lands on 1. The third roll of the die, it lands on 1. Then first 1 1, it's going to be a very, even if you decide to use a counting tree, it's going to be a very huge tree, too cumbersome you know, and I don't know how long that is even going to take. Okay, so now instead of doing it this way, it is easier to think of the problem in reverse. Okay, like we've already said before solving. So here, when we talk about failure, okay, what we are asking is that what is the probability that none of the rows will yield a 5? Okay, because here it's saying that what's the probability that on 3 rows of a die at least one of the rows will be a 5. Now we've reversed the question and then we asked that what is the probability that none of the rows will yield a 5? Okay, and so on each roll, okay, we know that there is what, a 5/6 probability that the die will not yield a 5. Okay, and so the probability that on all 3 rolls the die will not yield a 5 is what? 5/6 times 5/6 times 5/6. Okay, so here first roll, it will land on all other numbers except what? 5. Okay, so 5/6. Same here, same here. And then here we multiply all these together and then we arrive at what? 125 all over what? 216. Now referring to our formula, which is this one, okay, we can say that 1 minus failure, or 1 minus the probability of failure, is equal to what? Success. Okay, and so here we can say that 1 minus 125 all over 216, okay, is equal to success. And therefore success is what? This minus this, which is what? 91 all over 216. Okay, so if you want to find the probability that on 3 rolls of a die at least one of the rolls will be a 5, this is it. 91 over 216. Now try your hands on this question and see if you're able to solve it. Now here we turn our attention to the domino effect. Now domino effect measures the effect the outcome of the first event has on the probability of a subsequent event. Now here we have this example which says, in a container with 10 golf balls, 3 of which are painted blue, what is the probability of picking out a blue ball on each of your first 2 tries? Assume that you do not replace the first ball after you pick it. So here the probability of picking the first blue ball is what? Probability of what? Picking the first blue is what? There are 3 blue balls, okay, so 3 out of the total possible balls, which is what? 10. Okay, now remember here, once you pick the first ball, you cannot replace it or put it back into the container. Okay, and so that ball is gone, and you what? Pick probability of what? Picking the second what? Ball is what? So if the blue ball in the container is now 2 if we do not replace it with the first that has been picked. So this one is now 2. The total balls left is now what? 9. So here's what? 2 over 9. So here the whole idea is that you pick the first ball and it affects the outcome, affects the probability of, you know, the subsequent event. Okay, and so here if you want to find the probability, you know, of picking 2 blue balls out of the container, then you have what? 3 over 10 times 2 all over what? 9, which is what? 6 over 90, 1 over 15. Okay, and so some people will not, you know, solve it this way. They'll probably say 3 over 10 times 3 over 10, and this will be what? Wrong. Now try your hands on this question and see if you are able to solve it. Now here, try your hands on these 6 questions under the problem set. This brings us to the end of probability under the word problem series. See you in the next video.